This is video number 2 of 4.7, Transformations of a Polynomial Functions, and we are transforming a polynomial function. So for our core concepts, we have already talked about translating horizontally and vertically. Now we're going to talk about reflections. Now there are reflections over the x-axis and the y-axis, but we are not dealing with the ones over the y-axis. We only do, in our class, reflecting over the x-axis, and that is where you have a negative in front of the entire function. We also do not cover horizontal stretches and shrinks, so we're going to move down here to vertical stretches and shrinks. Okay, this is as the graph stretches away from or shrinks towards the x-axis, and that's always where you have a number multiplying your function, so it's out in front, and if it is greater, if a is greater than 1, it is a stretch. And if a is between 0 and 1, it is a shrink. Okay, so let's try problem number 3, where we are going to describe the transformation of f, represented by g, and then graph each function. All right, so f of x is my parent function. G of x is the new graph. So I need to determine what changed from the parent function to the new function. And it was this 3 out front. That is greater than 1. So this is a vertical stretch of factor 3. Or with a factor of 3. However you want to word that. By a factor of 3. However, okay? Now, if you just if you don't use the word vertical, that's okay, because we don't deal with horizontal at all. So if you just say stretch a factor of 3, that's fine. So this had no translation, did not move left or right, which meant the starting point stays at 0, 0. All right? And then if we go looking for points here, remember, the parent function is y equals x to the 4th. So if I plug in a -2 and I take it to the 4th power, I'm going to get 16. If I take -1 to the 4th power, I get 1. 0, 0 is our parent function, or is our starting point there. Okay, so that's like where we start from. And then if I take 1 to the 4th power, I get 1. If I take 2 to the 4th power, I get 16, which is off the graph. So these are just dealing with the parent function. Now, since we have a stretch of 3, so this is a, and it is no longer 1, I have to multiply all these y values by that number. Okay? You multiply the y values by whatever a is. Now, -216 is already way off my graph, so, you really wouldn't need to multiply that, but we know this does multiply into a 48. Still way off my graph. 1 times 3 is 3. 0 times 3 stays 0. 1 times 3 is 3, and again, this one's 48, but again, way off my graph, and it's off the graph going up, both of those. All right, so if from my starting point, I'm going to graph left 1, up 3, and right 1, up 3 from that starting point. These ones were off the graph, going left and right, but up. So it's very steep, and it'll look like that. Now, if you preferred, you could, instead of using these, you could have used the graphing calculator and typed in your equation and gotten your table. In this case, because there was no shift left and right, my table actually matches the points I got, and you can always graph it to double check that it looks correct. Now notice that x to the 4th is flatter than x squared. Okay, as that power gets higher, the bottom gets more flat. It is still a curve, it is not a point. But all right, let's try this with number 4. So number 4 has more than just a stretch or shrink. Okay, it's throwing in the translations with it. So this 1/2 put in front, that means A is 1/2, and it is between 0 and 1, means I have a shrink of 1/2, of a factor of 1/2, however you want to write that. Group with X, which means I'm moving on the X-axis left and right. Okay, it's a +2, and we do the opposite thing. So instead of going +2, I'm going left 2. And then I have a -1. That moves us up and down, and we do what it says. So -1 moved down 1. So I use these to get my starting point. From 0, 0, I'm going to go left 2, down 1, and I get a starting point. Then I get the other points I'd like to graph. Remember, this says your parent function is x cubed, and you can always just look at your function that you have and look at the power, okay? So if I cube -2, I get -8. If I cube -1, I get -1. 0, 0 is going to be our starting point. If I cube 1, I get 1, and if I cube 2, I get 8. All right, so from this starting point, we could just go ahead and plot these numbers, except there's an A that is not 1, okay? It's 1/2. So I'm going to take the y values, and I'm going to multiply them by 1/2. So half of -8 is -4. Half of -1 is a -1/2, or 0.5. Half of 1 is 0.5. And half of 8 is 4. So really, we could try to see if we could put on bigger numbers, like 3 and cubing it, and you'd get 27, and then half of 27. But I still don't think that'll fit on our graph. So I'm just going to leave this. It gives me enough points. So from my start point, I'm going left 2, down 4. I'm sorry, left 2, down 4. Make sure I did that. 1, 2, 3, 4. From the starting point, go left 1, down 1/2. From the starting point, go right 1, up 1/2. Go right 2, up 4 from that starting point. And then we're ready to plot. Okay. So we said the transformations, and we graph the function. Again, you can always check this with your calculator. So now go to your practice and do problems 12 through 15 and number 21.